Inside the servers that power modern artificial intelligence sits a tiny piece of silicon that acts as the physical brain of the thinking engine. Today, the company that designs this hardware, NVIDIA, commands a multi-trillion-dollar valuation and dictates the pace of global computing. But if you rewind to their founding in 1993, nobody on Wall Street took them seriously. CEO Jensen Huang sketched out the company's initial business plan in a Denny's diner. He simply wanted to build add-on circuit boards to process 3D graphics for PC video games. At the time, typical home computers were beige desktop boxes, equipped for spreadsheets and word processing. They weren't built to render immersive visual worlds. By catering to teenagers who wanted to dive into interactive digital spaces, NVIDIA inadvertently laid the physical foundation for artificial intelligence. Throughout the 1990s, Intel absolutely dominated the tech landscape. Their chips doubled in power every 18 months, a predictable rhythm known as Moore's Law. Intel built its empire on serial processing. This means a central processing unit, or CPU, tackles one highly complex mathematical instruction at a time, moving sequentially at incredibly high speeds. But a new problem emerged as PC games like Doom and Quake exploded in popularity. Drawing a three-dimensional environment breaks the rules of serial processing. To render a hallway on Mars, a computer has to calculate the lighting and position of thousands of tiny polygons at the exact same time, not sequentially. Gamers demanded smoother, more immersive worlds, and standard processors simply couldn't handle the geometry. This hunger created a massive void in the market, requiring an entirely new physical architecture to process the math. To meet this demand, Jensen Huang led the development of NVIDIA's first major product, the NV1 chip. It failed to support industry rendering standards. Customers returned it in droves, and sales plummeted. Facing imminent bankruptcy, Huang executed a desperate pivot. He laid off the majority of his staff, retaining only a small skeleton crew of 35 engineers to build a cheaper, generic graphics accelerator. Out of money, they couldn't afford to manufacture physical prototypes to test their design. Instead, they took a reckless gamble, using a crude software emulator to test the digital blueprints of the new chip and sending it straight to mass production. This blind leap paid off. The new chip, called the Riva 128, rushed to market and sold 1 million units in 4 months, providing just enough cash to keep the lights on. Surviving this trauma forged a permanent operational intensity within NVIDIA. They adopted a corporate mandate to constantly innovate, operating every day as if they were exactly 30 days away from total collapse. Legendary game developer John Carmack was pushing the limits of 3D shooters with Quake. He wanted hardware that could map a texture to a wall and apply a light source over it simultaneously. NVIDIA responded with a radical physical solution known as parallel computing, splitting the microchip's mathematical workload into dual pipelines. Instead of a single, ultra-fast serial processor trying to juggle every task in a line, a parallel architecture takes one massive job and fractures it into multiple separate streams executing simultaneously. For 3D rendering, this logic is perfect. The chip paints a surface texture on one side, calculates the light source on the other, merging them instantly on screen. Prior to this, parallel computing had a 0% success rate in the commercial market. Companies had tried to use it for serious scientific supercomputers, and every single one of them failed because the programming was too difficult. But video games constantly repeat simple, simultaneous math. It was the only environment where parallel computing actually functioned efficiently, leading to the massive success of NVIDIA's Riva TNT graphics chip. Huang recognized that he could leverage this momentum using a business strategy known as disruptive innovation, famously outlined by Harvard professor Clayton Christensen. The playbook is straightforward. Enter a market at the very bottom, selling lower-margin products to customers the major players don't want. In this case, selling graphics cards to teenage gamers allowed NVIDIA to quietly build massive scale. Legacy giants making powerful business workstations and servers completely ignored the PC gaming space. The margins were terrible, and video games didn't look like serious, profitable computing. By capturing a niche that the massive tech conglomerates dismissed as trivial, NVIDIA secretly built an insurmountable hardware ecosystem right beneath their feet. But buried deep within the silicon architecture of that 1998 Riva TNT chip was an unintended mathematical consequence. The precise parallel math required to calculate millions of 3D pixels simultaneously is identical to the math required to train an artificial neural network. Neural networks learn by processing thousands of small calculations concurrently. To absorb enormous datasets, they need parallel pipelines, not sequential ones. While tech giants like IBM spent millions trying to crack machine intelligence from the top down using traditional serial processing supercomputers, NVIDIA had already built the solution from the bottom up. Jensen Huang didn't set out to invent a thinking machine, but his desperate, all-or-nothing bid to survive the video game wars accidentally forged the exact physical infrastructure the world needed for the AI revolution.